66, we are given a capacitor of 8 microfarad connected to a battery of 6 volt through a resistor of 24 ohm. And find the current in the circuit just after the connections are made and one time constant after the connections are made. We need to understand what is time constant here. Time constant is a easy way of knowing, a quick way of calculating the things after a certain time, and it's defined as T is equal to RC, because in the formula we have, this is the formula that has RC thing here. So at time T equal to RC, it becomes easy mathematically to calculate the thing. Now let's say what happens just when we switch the current. The capacitor is not charged. The voltage you can think at this point is 0. Right after this, the switch connection is made, so the full current starts flowing through this, and that current is given by V by R, simply V by R. As the time passes, there will be more charge accumulation across this. For example, it's 6 volt, at some point in time it will become 2 volt. The resistance across this resistance will decrease to 4 volt and the current will reduce. But initially the current, surge current will be very high, and that will be given by V by R, or 6 divided by 24, or 1 by 4, or 0.25 ampere. That is the initial current. Later on, after some time, it start reducing to 0.2, 0.1, 0.05, so on and so forth, and finally to 0. When the voltage on this capacitor becomes equal to the voltage on this, there will be no current on this resistor. Now the formula for the charge on this capacitor is given by Q is equal to Q naught 1 minus e to the power minus t by RC. If you have any confusion on it, you can try to find its value of this charge, which gradually increases like this and exponentially. At t is equal to 0, this becomes 1 minus e to the power of minus 0, or e to the power 0. So this becomes 1 minus 1, or the charge is 0. When t is equal to infinity, this is 1 upon e to the power infinity, or 1 upon infinity, or 1 upon 0. So this is 1 minus 0, and the charge becomes equal to full charge. So the formula looks like good, but we need to find out the current through this circuit. To find the current, we differentiate this thing, becomes I, dq by dt is I. The rate of the change of the charge flowing through this circuit is the current I, and that is equal to, we differentiate it, the first term becomes 0, the second term is minus q0, so q0 is here, minus q0 multiplied by the e to the power minus t by rc has a differentiation, e to the power minus t by rc multiplied by d by dt of this thing, and d by dt of this thing is minus 1 upon rc here. Minus minus cancels, so the I is equal to q divided by rc multiplied by e to the power of minus t by rc. Now q naught is the final charge on this capacitor, that is given by CV naught. So CV naught, and then we can also write it, actually we could also write this formula as I is equal to I naught e to the power of minus t by rc, and we have already calculated the final value of I naught. But if you want, you can also derive it like the Q naught is the final charge on the capacitor given by CV naught, CC cancel, V naught by R naught, or which is I. I is 0.25 or 1 upon 4 multiplied by e to the power of, we need to find it after one time constant or RC. RC cancels, minus 1. So this becomes 1 upon 4, E is 2.71. So this we can roughly write, 1 goes away, let's say, then 4 multiplied by 2.7, 4 into 7 is 8, 4 into 7, 28, 8 here, 2 here, 4 into 2, 8 plus 2, 10, 1 upon 10.8, and this is roughly equal to 0.09 amps.